There are now hundreds of new electronic computers.
Okay, we should be good. Hopefully everyone can hear us here on the audio. Hello everyone out there. This is Side Pocket. I'm one of the two co-founders of DCG 201, formerly known as DEF CON 201 or DC 201. We are a computer hacker collective that meets the third Friday of every month. In fact, a couple of days ago, last Friday, we actually had our May meetup that was entirely based on virtual reality. It was really awesome. If you want to find out more details about it, you can go to our website at defcon21.org, which is what I'm about to post into chat. And we're also all over social media, so you can check us out on Twitter, Instagram, the hostducks.social, instance of Mastodon, GitHub, etc. But if you want to know those social media links, you can go to our website. Otherwise, here's a link tree that has all of the different social media stuff in here. Also, if you are on Facebook, because we are streaming this from Twitch Live or YouTube. In fact, if you like the content that you're going to see today and you want to know about upcoming shows that we have, including tomorrow's Archvile Linux Perspective, Crypto Barons, and Master of Unlocking, you can hit that bell on YouTube to make sure you get those notifications and like, share, and subscribe on Twitch Live and YouTube. We are also streaming on the Diode.zone instance of PeerTube, also NVIDIA's through Tor for the Elite Hack Source, and we're also streaming on Facebook, but there's sort of a weird way with chat. So if you want to chat with us and you're on Facebook, first of all, my condolences. Second of all, check out this link in order to get that info. Without further ado, this is Circuit Breakers. This is a show that all of the DCG 201 members put on. We do them on random Wednesdays. We try to announce them in advance, and this is where we look at mostly hardware, but sometimes software in order to like tinker with cool just gadgets that we have around. DCG 201 member sirocyl has an awesome thing that he's been working on. Unfortunately, he could not be here physically with us, but in the vein of sort of the virtual reality thing, he is going to be here virtually, and he has a cool thing to show to you, which is all about Google's Constant Experimental OS, Fuchsia, and the programming stuff behind it. Also, real quick, if you're on Twitch, if you are on Twitch and scroll below, we do have the GitHub, and that actually has the Fuchsia code in it. So if you want to check that out on Twitch, you can. Anyhow, well, we know I hate to dox you, but Long Island basically is your dead already. The only way it could be worse is Staten Island, but eventually you'll get back here into the safe zone. But regardless, let's tune over to the man of the hour, sirocyl, and he is going to take it away here on Google's Fuchsia OS and do kind of a hacker deep dive in it. So I'm letting him know to begin, and I'm going to now F off. Peace, everybody. Sorry, hold on. We had an issue. Damn it. I hate when this happens. I apologize. Hold on a moment. We're gonna go AFK real quick. This was my fault. I apologize here. Hang on. Ah, jeez. This is. Don't you love when this stuff happens? Hang on. This is. I hate this. I hate this so much. This is so annoying. Yes. Come on, open a new thing. Again, I apologize. We just had a quick technical difficulty on my end. Once again, apologize. This is what happens when I don't pay attention to anything, which often happens here. The reason why we're going to AFK is because, unfortunately, I have to log into a few things, which will display sensitive information here. So hang on a moment. Hold on a second here. And I just realized something completely different. Hang on, I'm going to reach out to sirocyl. I fucked up. Can you email me the SymfCall link again? It's in the chat. Scroll up. Ah, geez. So sorry about that. Essentially what happened is that in order to do the communication thing correctly in here, I had to self-mute. And when I went to unmute, unfortunately, because of the way GUIs are designed, the mute was put in the same section as the close part of the tab. So I accidentally closed out the entire remote video stream. Now, the good news is that the video stream is still there. The thing is, I need to get link access to it. which is a problem because because we're security conscious here. I also deleted those emails that had all the information on there, which means that sirocyl is going to have to reach out to me and send to me those links in order to display them here. This is what happens when you're trying to keep one group of tabs open and not the other. In fact, after this, I'm going to do the smart thing. Hopefully he will get the notification for this because, again, I do not have okay, so it's just sent, so it's going to come to me. Again, I apologize for this delay. This was entirely my fault here because it's DCG 201 is not an episode unless it is my fault somehow. And I'm just constantly refreshing the email in hopes that I get it. Maybe I'm going to check my spam folder here. Nothing in the spam folder. So it might just be a normal delay. Here we go. So once I load into the Symph call properly, I'm going to do what I should have done that I forgot that I could do because I forgot that this browser actually saves tabs. And once I enter in, I am going to close the other window so that way nothing can get confused and I can only focus on one window because that's what leet hackers do. Unfortunately, you were watching DCG 201. So we're going to come in on listen only here. It should be completely unmuted. I'm going to close the other thing. Listen only. Okay, so now everything is correct, and I'm going to type in go. And without further ado, we're going to pop back in and see sirocyl's lovely face here. So he's going to take it away talking about Fuchsia.
Okay, so what we have here is a freshly installed Ubuntu system. I'm going to go ahead and restart into it. The reason we're going with a completely fresh install is because, hold on, let's see here. So that's actually going to, yeah, that killed the desktop there, but I'm still here, thankfully. So basically, the reason I'm going with a completely fresh install is because we're building an operating system. This is big. It's going to take up a lot of hard drive space and memory. Thankfully, I have Ethernet run out here in the wild, wide open outdoors. So I should be able to get everything synced over, downloaded, and running. But basically, I'm just going to show you how it is to get Fuchsia going from nothing. And any fails that we encounter along the way, that'll be on me. Or, well, I mean, maybe on Google, because it's their system. But, yeah. Taking a bit longer to boot than I would expect, but yeah, it is a first boot, so who knows. Right now, we are just holding on for Ubuntu to reboot, because it being a fresh install, it's going to do its pre-configuration stuff. I wonder if X is actually crashing. Hold on. Because I'm not getting any feedback here on the computer. Hold up. I'm going to reboot this. There's a chance that the installation is damaged and it won't boot X11. That's okay, because I have a backup. So the computer I was going to use for this is a reasonably powerful, as everything goes into an avalanche over here, reasonably powerful ThinkPad P50. And heavy computer, takes a lot of resources to get it running, but I think X11 doesn't like the dual graphics on it because it's got discrete and integrated graphics, and being a fresh install with none of the drivers added to it, that's a pain. So I have backup, and that backup is this. a somewhat less powerful but still very useful T490S. So I'm going to get going on the backup computer and kill off the P50. And this isn't an advertisement for Lenovo or ThinkPads. I'm not paid by them or anything. I just like their computers and they just freaking work, except in this case. So let me just switch over to Big Blue button over here. Yep. And I'm going to share screen, entire screen, allow. Bingo. So now we have a different Ubuntu desktop. And yep, I'm just going to close some of these windows here. That's fine. X out of VMware because that's going to use up all my resources. Okay. Make a new window. Oh, shit. Well, VMware did the thing it usually does where it takes my mouse and I can't control the computer. That's great. That's fantastic. Which means I have to close the lid and open it again. So give it about 5 seconds. The desktop will disappear, hopefully, eventually. There it goes. Reopen the computer, and hopefully I should have my mouse back. That's a bug in VMware. Yep, I got mouse. Perfect. Let's see if it restores my synth call. Minimize that. Minimize that. Where's synth call? This thing. Okay. Losing your connection was detected. Screen share has ended. Okay. Share entire screen. Allow. Now I should be back. All right. Cool. Now, back to the stream monitor. Minimize this. Get rid of that. New window. Cool. So, starting from scratch. So Fuchsia is Google's new operating system. It's open source, somewhat of a proprietary thing because they didn't GPL any of it. It's all BSD, MIT and stuff. So like drivers for hardware, they aren't obligated to open source that. That's a bad thing in general because it means that, you know, parts of Fuchsia aren't going to be easy to port. But they do have a port for PC. It'll run in QEMU, which is the plan here. So let's get started. So I want to get Fuchsia and build Fuchsia. So restart, run the pre-flight. Pop this over here. Dev, Victor, OS dev. Oh, over here. Victor, Fuchsia. Okay. Let's zoom this in a bit. Oh, it doesn't even have kernel installed. Okay. And install. Okay. And there we go. Now, running, sure, why not? And we don't need to be sending analytics. Welcome to Fuchsia. These are, okay, found supported graphics hardware. NVIDIA hardware could not be detected. I don't have NVIDIA hardware on this machine. TUNTAP device named QEMU for the current user. Access for the emulator. Okay, that's fine. So, no, I don't need to be running that a second time. Why didn't it copy? FFX config analytics disable. Copy and paste. Okay. It didn't set up my environment. Okay. First up, let's set up my content for this instance. Copy and paste. Bingo. And turn on this. Okay. Okay, good. Hopefully that doesn't break the connection on my VMware. So let's run this again and see if it does anything different. Okay, good. Continue at, and there's the link. So I think I already have these installed, but I didn't have curl, so that's fine. Go ahead, auto remove. Get rid of these old Linux updates. Okay. Download Fuchsia source. Okay. Run the bootstrap script. Downloading Fuchsia source can take up to 60 minutes. Ooh. Well, if I have to wait here for that long, then that's going to be screwy. Okay, creating project Fuchsia. And let's just monitor what the system is actually doing here. Yeah, it's busy. It's got a few threads running at half. So that could just be the desktop streaming. Yeah, so I've got 80 gigs free. Hope that'll be enough. Yeah, it's probably going to be busy for a little while. That sucks. I had Ethernet running, but now I have to rely on Wi-Fi, and this Wi-Fi only has like 4 bars, so. All right. So while this is running, let's see what it's actually doing. So that's binary. That's not a script. All right. Yep. So that's interesting. It pulls down a whole binary for that. Let's go to Fuchsia. Yeah, it's got Jerry. It's an integration folder. I don't like these terminal colors, but it's the best we can do for now, I guess. I don't know. I'll change it up. Preferences. Colors. Okay, let's do no dark. That should be a little bit more readable. All right. So it's creating Project Fuchsia. Let's check the usage here. Yep, it's filling up my hard drive with something. So I guess while that's going, yeah, now it's adding more stuff to it. Build tools, docs, examples, pull in the Garnet kernel, Topaz, and Zircon. So Fuchsia names a lot of their stuff after precious rocks for some reason. It's just a thing Google decided to do. I think Zircon was called something else, like it had a color name. Like there was fuchsia, and then there was like purple or pink or something. But they changed all the names to make a cohesive system. I guess it works. Yeah, so now it's in all the different project files for everything. So, while Fuchsia builds, I'm going to actually look at Haiku, which is another operating system. So, interesting thing about Fuchsia is that it's based on a kernel called New OS at the start, which New OS evolved into LK, which is used as a bootloader for Android. One second. Okay, never mind. I thought I had someone trying to tell me something. So, Fuchsia is based on the LK kernel, which LK was used by Google in a few different things. They used it in the bootloader for Android, A-Boot. It boots LK and uses it as an environment for pulling in bootloader services and things, emergency flash and download, things like that. Google, I think, used it for some recovery systems and some phones and other devices. And as far as Haiku pulled from its grandfather, New OS. The kernel was made by Travis Gesselbright, and I'll actually pull up its website here. New OS. So, okay. Give it a second. This internet ain't great. Okay. So, New OS, its website's still up. Implemented in C++ and C. Sources available. And the interesting thing is it's so old that they're still on... no, wait, never mind. They actually have a Git server now. Okay. I was about to say they were on Subversion up until rather recently. However, git.newos.org does not have a browsable source code. Because they moved to GitHub. Makes sense. So, if you're wondering why it's so dark out here, it's because it's dark out here. It's I had to do this outside because I'm over at my parents' house, and there's really nowhere inside that I can actually do something like this without being interrupted or hassled or something. And there's a chance, actually, that in about between 30 minutes and an hour, I might have to pack up and close this down because, oh, wait, no, maybe not. There was a special, weather warning that there was going to be a severe thunderstorm, but that must have blown south of us. So it's not raining yet. But if and when it does start to rain, I will have to close up shop here. So let's hope this can be done before then. Yep. So let's check the GitHub. So New OS is rather well put together. Source code was last updated 15 years ago. Yeah, there was an update in 2010, but yeah, most of this is 10 to 11 years old code. So I wouldn't recommend pulling New OS for something, new, because it's not exactly a new OS, but it's well put together. It has a few basic apps here, like virtual memory statistics. They ported Fortune over. Some GNU-like utilities, core utils and things. The kernel itself is reasonably small. It's not a microkernel, it's monolithic, but everything is readable. Everything's put out in its own It's compartmentalized, I should say. File systems, so yeah, I do believe it only supported one FS out of the gate, and I think that's either FAT32 or if it's got its own OS here. Root FS, cookie in jar. Okay, that's fun. There's a function called insert cookie in jar. I'm guessing that's for a atomicity, to make sure that, when you shut down the operating system unexpectedly, it can recover from its previous state without a corrupted half-written file being somewhere on the drive. I don't think it's a journaled file system, though. So it's only got a basic cookie for tracking. So let's see how Fuchsia's getting along here. It's okay, pulling in all the third-party projects. How's my hard drive looking? TF-H. So, yeah, I still got 70 gigs free. Hopefully that'll be enough. Otherwise, I'm going to delete the Haiku tree. So, Haiku is a rather interesting OS because it's very desktop-oriented and stuff. It's put together with BOS compatibility in mind, but it advances far beyond that. So it's not, it's not stuck to its roots where it's not going to try and upgrade anything with that for fear of breaking the compatibility, because they've already got a port for ARM, x86 64, PowerPC, and original BOS never had that. And those ports are advanced further. Originally they had Haiku building with GCC2 so that it would be compatible with the BOS ABI. However, they introduced a hybrid ABI where it can be built with GCC2 and GCC4. And then the GCC4 ABI continued to advance, and now they're using more modern compilers. I think it actually pulls down GCC9 for the compilation. So I'm going to update my code here. See if there's been a reasonable amount of updates to Haiku, and of course there were. All right, Haiku has been updated. Let's make sure the build tools have also been updated. Yes. Okay, cool. Okay. All right, so that's been updated. Yeah, as you can see here, they have a AArch64 ABI already well underway, and they're actively developing on it. So the reason I bring up Haiku is because it shares a genealogy with Fuchsia, and I do kind of need some filler while Fuchsia does its thing in the background. Okay. This has actually made some progress. We are now fetching CIPD packages. I felt a raindrop. So yeah, I'm not sure if you can see the sky here, but that's not looking happy. So there's a chance that I do have an umbrella that I can set up here. I will pull that down and try and continue with the rain around us, which is exciting. But it does begin to get more stormy and windy and stuff. I'm gonna have to pull down and head up. So, well, I'll keep you guys up to date. I'll let SidePocket know. All right, so we are continuing to fetch CIPD packages. So let's see, what is CIPD? Let's actually pull up the window. Fuchsia CIPD. So, yep, those are raindrops. Hold on. I'm just going to get the umbrella, so hang tight for 5 seconds. Stays up here. Don't get too windy. All right. Let's shift this over a little bit. All right. I now have an umbrella set up. Hopefully this should provide some relief from the impending doom. So CIPD is a tool that generates YAML files. No, wait. This is to produce archives to upload to CIPD. I'm guessing CIPD is their package manager internally for building and downloading Fuchsia. Because, and look it up, there's a lot of mentions of packages and things, so. Taking its time. I wonder if adding the umbrella actually hit the Wi-Fi. Yeah, so integrate software with Fuchsia project. Yeah, it seems like CIPD is, there we go, Chrome infrastructure package deployment. Oh, that's interesting. So it's a piece of the Chrome build infrastructure. Interesting. What's Lucy? Layered universal continuous integration. Okay. Well, Google has all of that open source. So you could build a project in the same way Google does. Now, whether you want to, on the other hand, that's questionable. But yeah, so CIPD is just a package manager for their build infrastructure. Brings in things that other things need to function in order to build the system. Now, going back to Haiku real quick. All right, so let's check the options here. So I don't think I need to put the cross tools. I should have them already prefixed in. Include target bar, choose claim, use JCC. Let's see. I do have a build already out in build. Maybe not. Oh, that's where I put it. Okay, so let's close this. Fuchsia is still doing its thing. So Haiku recently got into beta 2, which is a massive milestone, a huge step forward. Continual development, continual setup here. So it's like rather mature operating system, despite the fact that it's still kind of beta, still kind of setting up and doing its thing. Doesn't have a multi-user setup like Linux does or Unix, but it does have a POSIX API under the hood, so you could theoretically have multiple users. So what I want to do here is look at how to build this. Should be in the guides here. Installing, virtualizing, booting, unifying, daily tasks, building Haiku. Here we go. So I got the source code I want to compile for x86-64. Okay, that seems straightforward. And build tools should be, yep, available. So let's do it. It's doing the usual configure thing, checking for all the weirdnesses of C, making sure I'm not running on like SGI IRIX from the 1990s. See, this is a thing I don't like about most C projects. All of these configure lines for checking if this or that, checking. I genuinely don't think it's necessary much anymore because most, I won't say all, most builds have standardized around GCC or LLVM and Clang, with a few stragglers out in the field for things like Green Hills Multi or LCC, TCC, things like that. Those are rare. So what I figure is the configure step should just fingerprint what your build environment is rather than whether or not your library is capable of doing VS and printf. It should just fingerprint your build and run off of a cached set of checks and tell it, we have things already set up for this particular compiler. So, yeah. I just checked the chat. Yeah, that's it's definitely a great idea. So far, not much rain. It's just it was drizzling earlier and it went away. It's like one or two little drips here and there. So see, if I was forward thinking, I would have brought better lighting here. Because right now I kind of look like I'm like in the middle of like actually, hold on. I'm gonna see if I can flip on a light real quick. Little chance of this working, but I'll be back in like a minute tops. Nope, light switch didn't work. So, all right, that's all well and dandy. At least the umbrella's still holding up. Not quite raining just yet. So, I guess it is building the build tools here. Hasn't encountered an error yet, knock on wood. Fuchsia is still fetching packages. Let's see, how much hard drive space have I lost so far? We have 59 gigabytes free. Okay. Reasonable. just for the hell of it, I think I'm going to go try and build new OS. So let's see, where was the window I had? No. And if you happen to see a bug crawl across the camera or something, I'm outside. That happens. All right, so let's clone this in. Okay, that was quick. Okay.
Thank you, Homemade Pain, for describing to us on YouTube.
See the to-do here. Hold on, I actually can't hear the microphone at the moment. What was that? Okay, let's see here. So this doesn't give me any information on building this thing. Let's boot DC. That's a script. And that does... Okay, that's for net booting the kernel out to something. I don't need that right now. Let's look in tools. So, bootmaker, there's a make. Oh, I see. There's a make file. Didn't see the make file because it was so small. Put a lowercase m on it. Oh, okay, okay. I didn't even notice. So thank you for following us, whoever did follow us. We definitely appreciate followers on YouTube, DLive, Twitch. So go ahead, hit that like button, subscribe, share our channel, do the things you do. You guys are awesome. Thanks for watching. So I'm right now I'm just looking at the make file here, and okay, so it seems all put together. I'm hoping that if I run this make file, that all these rm.rfs don't wind up blank and then like deleting my root directory. That would be not fun. So, okay. What are my targets here? We have make all, yeah, that just through. Clean, depth clean, all clean, spotless. So I think make all is what I'm going to have to run here. And error already. So, oh, okay. Yeah, this is some ancient code actually. There's a freaking mosquito on my screen. Custom new OS toolchain not found. Download the appropriate toolchain at newos.sourceforge. The mosquitoes are getting out here. So, yeah, Haiku's still building. Oh, has this finished? Some packages are skipped due to lack of access. CIPD auth login. Oh, I think that's because there are some packages that Fuchsia pulls in by default, assuming that you are a Google employee and have access to the source tree for all the secret Fuchsia stuff they're working on. Now, obviously, I'm not a Googler. I don't work for Google, and I don't have special access to it. Oh, shut up. I kept saying the G word, and my phone kept lighting up. So, being that I don't work there, yeah, there are parts of Fuchsia that I can't access, but the operating system should at least pull down and work just fine. So, now that that step is done, let's move forward. Fuchsia source code. Okay, bootstrap script. PC invalid. Your Git cookies may contain something. Interesting. The on-screen. Delete the offending cookies from the Git cookies file. So, while I do that, I'm actually going to. Well, first off, do I even have a Git cookies file? I only have a git config, no git cookies. Config / git. No. So I shouldn't have a problem with that. Haiku is still building its build tools, as expected. New OS won't build, so you know what? rm-rf new OS. Because there's no way I'm going to be like traipsing through an old SourceForge CVS to try and get the tool chain to build new OS with. That's a non-starter. Right, so what's our next step on Fuchsia here? Copy the tool in your binary directory. Oh, is that the rain? Well, the umbrella's holding up. Cool. If I see thunder though, if I see lightning, that's gonna wrap it up. So if that happens, I'll let you guys know, and I'll be out of here with the quickness. So that's just a heads up to anyone viewing right now. Fuchsia source code. Right. So I need to add this to my bash profile. It assumes that it's in my home/Fuchsia directory, but it's not, so I'll have to edit that. Bash _profile. I guess .profile works. Yep. Export path equals Fuchsia development /os dev /Fuchsia okay, and source environment. Okay. Okay, I should be in a Fuchsia environment now. Cool. So, yep, that works. Now, let's copy that and paste. Run it. Okay. just opting myself out of the analytics because I don't need Google tracking everything here. If I was actually doing, contributory development towards Fuchsia, I would probably leave the analytics on and do this on a dedicated machine that isn't something I share with things, which was the plan originally with the ThinkPad P50, but that was having a headache, so I had to put it aside. Haiku's still building the tools. That's going good. So next steps, configure and build Fuchsia. Oh, FX set product / board. Okay. I guess I'll set up for an emulator, so core.qemu64. Goma. Yeah, like I'm actually a Googler and can use that. Hell. Okay. Let's try that again. Also interesting, all this work my computer is doing is heating it up quite a bit. It's actually to the point that I'm concerned about putting it on top of this other laptop here. So I'm going to go ahead and pull these wires up out of the way. I'll get this computer. Apologies if there's any clunking and clanking noises. I am monitoring my own stream on these headphones, so I can hear if anything has gone to whack. So, all right, that is done. Let's just FX metrics disable. Okay, it's already disabled. It's a good thing it is opt-in rather than, oh, we'll just assume that it's already running by default. Okay, I do not need to use Ccache. Famous last words. Build Fuchsia. That's it. FX build. That's the step. FX build. Fuchsia's building right now. All right. Let me check my hard drive usage. We have 58 gigs free. That should be enough, all things considered. And it's going through with the quickness. Got 40,000 things to compile. Cool. Rust. So I guess Google's no longer, I'm sure they're still using the Golang, but they're not, evangelizing it as much to the point that you can't use anything but Go for tools, because I see Rust. So I guess they've moved along and they're now using Rust for things. That's neat. Haiku's still building its build tools. See, it's got to compile GCC for that, which is why it takes so long, because GNU. So it's doing all the GNU stuff. It's got to run through everything, test everything, Granted, GCC is rather well engineered as far as a project that's as large as it is and as not exactly corporate as it is. They do pretty good for what they got, but it's got its own idiosyncrasies. It's got its own headaches and hang-ups. So, checking the chat, and there is spam. Let's ban these. And I guess these bots just assume that you can just run a stream and you're not watching the chat. Watch a lightning bolt hit N-Commander's. N-Commander has a TRS-80? Who told? Nobody told me this. Okay, so things are still building. Fuchsia's still doing its thing. We're at 3,000 of 46,000. Haiku's still doing its thing. We're at somewhere. That's the great thing about GNU is that you just have to guess where you're at in the build progress and hope that you're right. Let me see how much CPU is actually being used up. It is maxed out. All 8 cores are pulling all of their weight. Memory is fine. I've got 16 gigs and it's only using up 4 of them. So maybe if when Haiku's RTL anal, that okay. I was not expecting to see that in my terminal. All right. So there's proof that GCC can be anal about things sometimes. And that's probably the code where it does it. So, 3,000 and still going. GCC, ooh, warnings. GCC isn't supposed to produce warnings. You guys should be checking your own code. Come on, GNU. Okay, it actually looks like it might be close to the end because I know it runs in alphabetical order. And we're on S, like stack pointer, statement, storage layout, storage motion, streamer hooks. Huh. That's what we use for stream. Target hooks, time variable. So it's just, yeah, we're at T out of A through C. So that's going to be done in a few minutes. But the other thing you have to compare is look at how slow GNU is compiling what it's compiling, running through every source file. And then Fuchsia's just like compile a machine go burr. It's like quite a contrast. And it's not building like small time code. It's not running through tiny shit. This is the crypto library, boring SSL. So, yeah. I mean, I guess compiling a compiler is an inherently slower operation, so yeah. Okay. You know what? As if I wasn't crazy enough already, let's build the AROS research operating system. This has no relation to Fuchsia or anything else other than the fact that it's just another alternative operating system. But the thing with AROS is that it's built to pretty much emulate Amiga in terms of its architecture. So it has a lot of the similar APIs for graphics, video, operating system services. And with that, it allows you to port Amiga OS applications from source to PC directly through AROS without any recompiling, without any headaches or anything. If you hear that behind me, that's a raccoon chittering. I'm hoping it doesn't jump down and try to attack me. Don't want to catch rabies. So, let's close out a new OS. Let's see what it takes to build AROS. So, installation using shell applications, how to. Developers, contribute roadmap, issue tracker. Let's pull down the Git. So, thankfully, they've advanced to Git. They are no longer using this version, which is great. Also, apologies if my screen is tiny, because that's just the way they designed this website. All the text is real small. So, GitHub host and repository. Unix, yes, okay. Getting the sources. It's simple enough. All right. Go back to the terminal. Fuchsia is still going. We're at about 1/10 of the way through. Haiku is, yeah, it's at T out of alphabetical order, so it's gonna take a bit. Let's make her AROS and clone this down. Oh, so I should zoom this in too. There we go. So you can see that. This I'll leave as it is. This, you can see that. Cool. Okay. A bit of a large code base here. It's 180 megs pulling down right now. Yeah, just almost 200 megs. So AROS has quite a bit of stuff in it. No idea if it's bloat or if it's actual useful code. But considering that a leaf just blew on my computer. Considering that AROS can be built to fit on a single floppy disk, because it is just Amiga OS pretty much, I'm willing to bet a lot of that is either bloat or like unit tests and build automation, things like that. So let's just check my battery status. Yeah, it's at 92%. I've got this computer on a USB-C charger that isn't exactly full power and full strength, so it's going to slowly drain the battery while it's running at full tilt, but that's to be expected. Okay, so AROS is pulled down. Looks simple enough. So we also need to pull down contrib and ports. So let's go ahead and do those. So why did the inspector pop up? So they tell you to git clone all of this .git after doing a makedir, but honestly, you can skip a lot of that and you don't need the .git at the end of the URL. So I'm just gonna clone that down. Get this one ready for ports. Okay. It is actually raining out now, so cool. Let me just do a run around and make sure that all my stuff isn't getting wet. It's a bit damp in the corner here. Power jacks, yes. I'm gonna have to move the power. This over out of. Okay. Bag here is. Okay. And I just gotta move this thing. So apologies for the sudden weirdness here. I just had to move some things around. Okay, now things should be safe. The power brick is out of the rain. Everything is under the umbrella, as it should. All right. Here. That will do. That will do. Okay. So, right now I am coding in the rain, in the dark. So, that's a first for our stream. I'll actually, let me get the light up so I can show you what's around here. Yeah, so I'm just outside and it's actually legitimate raining. I wasn't kidding about the rain. I'm under an umbrella, so that's fine. There's mosquitoes flying all over the place. And it's like camping. Wish we had some mosquito spray or something. Okay, so that's done. Now I need to pull down the ports. That was quick. Okay. So, after the clone, yep, okay. Now we need to do the submodule thing. Woot. Why is it that... Okay. Paste that in, and that's a lot of submodules. I guess it's every part of the AROS tree is its own submodule. So the different libraries, all the different components, they're componentized as get submodules in the source. I guess that saves them from having to use a proprietary package manager like Fuchsia does. Fuchsia is now at 5,000, almost 6,000 out of 40,000. Haiku is doing its thing. Still building the build tools, still doing GCC. That is all done. All the submodules are in. Extra sources. I don't think I need all that. So, all right. So the sources are got. Now, what about building? Compiling. Requirements. Okay. Now, do they give us a simple line for getting all these components? No, I don't think so. Python Mako 3, switch library utilities. I think a lot of that is already covered by Build Essential, which sudo install build essential. I believe I already have that. Yeah. So I think all the stuff's already in, and if it's not, then well, good luck. All right, configure. Has a couple of options here for configuring it. Debug, Ccache, port sources, C compiler, optimization, actual chain. So I'm going to want to. I think I'll try to build the hosted version first. So that'll run under, well, okay, hold on, because it's i386. See, I don't think AROS has 64-bit support in it. So that's probably not going to work. So I'm going to actually, yeah, it already says you can build 32-bit versions by providing an option such as, okay. I have no idea if doing that will try to pull down i386 libs and fill my computer with all sorts of cruft, but I'll give it a shot. I'll build the hosted version and get that running. So what I need to do is .configure with target Linux i386 /configure target equals Linux-i386 i386. Let's go. All right, so it's doing its thing. I don't have PNG to pin it. So Ubuntu is kind of easy mode as far as Linuxes go because you can put in a command that doesn't exist and it'll tell you which package you need to install for it. So sudo apt install netpbm. You can certainly do that manually by running your package manager and doing a tree search through the packages, but that just complicates things in my opinion. Command not found is an excellent user experience. Sugar. It's sugar. It adds to the experience and makes it work. Yeah, the real code camp. That's pretty much where we are right now. Not sure if you can hear the rain and frogs, occasional mosquito buzzing around. All right, so AROS is should be ready now. Let's configure. What are we missing? Fail to detect Mako. I don't have Mako. What do I have to do to install Mako? Is it just pip-i? Python Mako 30. So sudo apt install Python 3-Mako. That should do it. Rain's coming down. I'm just going to monitor and make sure the water's not pooling up on the table here. Just gotta move this in. Alright. Fine. Make sure this one is under the umbrella. Damn it, I didn't want to drop that. That's good. Danger. Hotels on here. Okay. Sorry about that brief intermission. I just had to make sure that my stuff wasn't getting all wet and rained on. Because if you couldn't tell, I have electrical equipment out here. And this is the power strip for it. Keeping it under the umbrella is a good idea. So it seems like that's done installing. I'll kill off the light here. There we go. Let's move this over here. I hate these cables. There we go. Python 3 Mako. should just be able to run my configure line again. PNG. Try again. Oh, seems to be getting a lot farther now. It's doing its usual GCC autoconf check, and it's configured successfully. Sweet. So we ran the configure script. All I should need to do is run make. Yep. Excellent. So hosted. If you're building a host, you should also additionally run the phone. So first we'll just run make. And that is spooling right along. This is still going, and Fuchsia is at 8,000 to 40,000. Okay. Let's see how my system status is. All 8 cores are spinning at max. Hard drive is still got 50 gigs free. Cool. So AROS is running nmake rather. I guess that's like a meta make file kind of engine. Pulling down bin utils. Okay, this is all the toolchain stuff for AROS. So it's going to pull it down, unpack it, and build its toolchain, while Haiku is building its own toolchain, while Fuchsia is doing its thing with Rust. So 3 operating systems building in parallel on a laptop in the rain. Oh, Lord. Okay, so has a few patches to the toolchain for it to make. AArch64, I didn't know. Wow. Okay, so AROS is getting a port to ARM64 and AArch64. Neat. That's going to be interesting to run on some embedded hardware. I'm thinking ports to video game consoles like the Nintendo 3DS, or hell, even the Nintendo DS. And its requirements are absolutely minimal. Consider that Amiga OS was supposed to run my 68020, maybe even a 68,000, with like a megabyte of RAM. Nintendo DS should be able to pull its weight. DS has a 96 megahertz ARM9 processor in conjunction with an ARM7 subprocessor used for I/O and backwards compatibility with Game Boy Advance games. That runs at, I believe, 32 or 33 megahertz. But with the ARM9, Nintendo DS has a weird memory map where, like, there's shared memory and then there's different zones for like VRAM and IRAM, fast, quote unquote fast RAM, but it's really tightly coupled memory TCM. You have ITCM and DTCM. Okay, both these tool chains are spinning right along. I'm gonna zoom this out so more fits on the screen. Fuchsia is still at 8,000 out of 40,000. Hold on 1 second.
Well, thank you, 16-Bit Wonder, for following us on Twitch.
I just had to, my mom showed up. She just wanted to make sure my computers weren't getting rained on and that I wasn't getting electrocuted. Okay, so this is spinning right away. These are both building GNU GCC tool chains, as they should be. Fuchsia's, see, the other thing about Fuchsia is it's kind of nice that it's just this one line at the bottom with a progress counter, but it doesn't show you a lot of what it's doing while it's doing it. So you don't have the cool matrix scrolling text screen kind of stuff. All right. These are going. I'm getting a little hungry. I might go and get some chili out of the pot in a few minutes, but we'll see how this goes. And so far, the umbrella is holding up well. Nothing's getting wet or rained on under here. Just make sure that this water is cooling up on the table, because that could be not. Yes, it's not being a problem right now. None of the electrics are getting wet. Yeah, okay. This is going along reasonably well. Yeah. So. Okay, so this is building all the GCC debug stuff. This is done. It is done configuring and building the bin utils and GCC for cross compilation. So Haiku is now ready to be compiled. Yeah, it wasn't actually compiling Haiku that whole time. It was only getting it ready for. Fuchsia is 8,000 in. It's doing fiddle compiling and stuff. So fiddle is the Fuchsia interface definition language, because Fuchsia is a microkernel. The way it works is that you have different services that are hosted by the kernel itself, and they have to talk to one another. And for security, you don't want to just pop a shared memory allocation and have everything write to it willy-nilly, because if someone's writing some unsavory data into there, you don't know how the target application is going to handle it. So what Fuchsia does is it uses an interface definition language called fiddle. Yes, that is kind of an accurate description of Haiku, actually. Just the dependencies we made along the way. So Fuchsia has an interface definition language that strictly defines how different services in the microkernel architecture communicate with one another. And that goes a long way towards making sure that the system is stable and secure. It provides a closed loop, pretty much, on what systems are communicating where. So doing it like that is definitely better, because it reduces the surface area by a lot on how you can get into files and things that are being accessed by other services in the Fuchsia operating system. All right, so it is linking together GMP, and that is done. So yeah, just putting together all the things that GCC needs. Fuchsia is steadily going along. It's nearly 10,000 now. Doing all the small code maintenance stuff to make sure that everything's being compiled the way it's supposed to be. Love the smell of fresh rain at night. All right, so just make sure this mill is stable. Yeah. Freaking mosquitoes. The mosquitoes really like the computer for some reason. You see the light of the screen and they're like, ooh, shiny. Okay, 12,000. This is actually going through rather quick now. Well, it's not compiling anything. It's just doing maintenance, pretty much. Just stamping the files, making sure that the timestamps are changed on them so that the build system knows, yes, this has been updated to this point in time. That way, in the future, when you rebuild, it doesn't actually have to compile that file. It just knows that it's there and skips over it. That's pretty much how a lot of these build systems, even Make does that to an extent. So they pretty much, they had a good idea of what they were doing as far as doing build automation and stuff. I just hate the syntax of Make files. I'm sure we all do. And all the alternatives don't work very well. Like auto make has its own idiosyncrasies, and a lot of people don't like it. CMake, there's people who do actually appreciate it and prefer to use it. A lot of people see CMake and groan. Ninja is a decent compromise. It does a lot of the build automation stuff that you would think CMake should do. Does it in Python, so the syntax is quite a bit more clear. And it's what Fuchsia actually uses under the hood. I'm surprised they're not using like Bazel or something, Google proprietary like that. I think they used to actually use Bazel way at the beginning of the Fuchsia project. Like I said, I was building this since the kernel was still called Purple, I think. Okay. And it's putting together the next part of GNU, which is ISL. Wonder if we can get, let's see what our CPU utilization is. All 8 cores are still maxed out. File system, we have 46 gigabytes free. So let's actually compile Haiku. So Haiku actually uses its own build automation system called Jam. To understand it to the fullest extent of the Jam, it's essentially what if we did Make in C++ and had a very strict language, a task-specific language just for handling, do this, then do that. So it's like a job control language, essentially. But the benefit of doing it that way is that you don't have the weird idiosyncrasies with Make, where it's kind of like, it's kind of a shell script, but if you want to do shell things, you have to wrap the command in a weird $sign. You have to stick sigils all across the file. That's a thing Make does that Jam doesn't. Jam files are pretty much upfront and readable. So actually, let's look at the Jam file that's been generated for this build. And yeah, there's not much to look at here. It just defines that the top directory is the one above this one, and that the output directory is this directory. Simple enough. So let's look at the root Jam file. And it's a simple declarative language that tells you what depends on what, where, and pulls in the information as it's needed. So the rain is getting a bit heavier. I worry that water's bouncing off of things, getting on computers here. So let me just do a real check real quick. What? Yeah. safe. I think we're still safe here. We're still good. It's just over here starting to get a bit wet. Oh, that's what. The umbrella's raining off onto the grill behind me. So if I turn the umbrella, it should change that up a little bit. Yeah, that should do it. Okay. All right, so yeah, like I said, it's a domain-specific language, task-specific language, just for building things like Haiku. It was originally written by Perforce years and years ago. Haiku forked it off because it was open source and they wanted something that wasn't Make, and that honestly that was a good idea on their part. So they went with their own thing, and yeah, that pretty much that filled it out. So I'm about to build a J2. I want to make that a J4, so jam-q-j4 at nightly auto. Oop, is that it? Any group. Let's check how hot this computer's getting. Reasonably hot. It's not too bad. Thermals aren't too much of a problem because it's not hot outside, so there's a light breeze. It's not windy, but keeps the computers cool. So AROS is still building its toolchain as expected. Let's jam this down. Building a Haiku tonight. This is about halfway through, 24,000. Yep, right now it's just compiling the fiddle compiler and all the interface definitions. So from the way it looks, fiddle is meta-compiled. It's transformed from fiddle lang into C++ code that's integrated into the source tree and then built into the program, which that's a neat way of doing it. Keeps things well defined and well managed. There's a tweet that I wanted to bring up here. I could probably get to it from search. Okay. Fuchsia. And the browser is going to be a little bit slow with heavy web apps like Twitter, just because it's doing all that other crap in the background. So Fuchsia return void. So there's an interesting behavior about Fuchsia and its syscalls. In particular, this is a rather neat security trick. It returns void on the syscall for generating random numbers. And the reason for that is that the kernel will entirely crash out if there is a fundamental error in such a high security function as to draw numbers from the PRNG. And that's important because you wouldn't want it to be just assuming that the numbers are correct and drawing them without double checking them. So as Adam Barth here explains, the syscall can fail, and if it fails securely. It fails safe by going directly into a panic handler. It doesn't even wait for the return value to get back to the program and get used. The kernel will panic, and you'll know why. So yeah, if it's an invalid buffer, it'll just kill the process because you did something stupid and the kernel catches it. If the process doesn't terminate, then the calling thread will just spin lock infinitely and never return. So that's actually a neat trick to the design. And makes it easy for implementing high security code without worrying about high reliability data handling and things like that. And yeah, actually, as mentioned here, no e-fault question mark. And yeah, it returns invalid args for things like bad addresses and things like that. But for high security things like drawing from the PRNG, you don't want it to do that, because if it returns an error, then it can return anything that could be handled by a high reliability usage-based process that's really depending on that random number to be there and to be absolutely random. So it's not going to return, it will terminate and crash out. Oh, absolutely. I'll share these tweets. I'll pop this thread over into Twitch, actually. So, copy link. All right, I have that on the other computer. So, let me just go over here. Mind the keyboard noise, because I'm going to type this into chat. Assuming I have chat open. Where is it? There it is. No, that's not it. There it is. Expand. Cool. Mind the keyboard noise for a second. One, 3, 9, 5, 8, 8, 6, 7. 1, 2, 4, 1, 9, 7, 2. Okay, that should be the link to the tweet. And yep, it is. Cool. There's an ant on my screen. Okay. I didn't need a close-up right then. Okay, so Fuchsia is 25,000 out of 45,000 done. Haiku is rolling right along. It says it's on 2100th target. Yeah, so it's been doing it's been quite busy in the background since I left it. All right, 2200th target. It is building interface kit. Interface kit's a cool thing about Haiku, where it it keeps all the UI stuff in its own library. All the widget toolkit is custom in Haiku, so the way it does it is a rather neat object-oriented framework that allows for redirecting the user interface from being a part of the process space to being a service that you communicate with from the process. And in my opinion, doing it like that is the way to go. It's beneficial because UI doesn't hang when the process is busy. And sure, you could spin off a thread in the process for handling the UI, but why bother? You could just have the UI be its own thing and communicate with it through IPC. And Interface Kit seems to do that, and it does it rather well. Okay. This is moving right along with the quickness. Let's see over here. Okay, it's moved on to building another part of the tool chain. And Fuchsia is still 25,000 deep. It's now building SPRV tools. SPRV, S-P-R-R-V, is a intermediate representation of code for running on shaders. So Your GPU runs these things called shaders. It processes data going into them, usually visual data and things like textures and meshes and models. And it processes these and runs them through a highly parallel program that's run on hundreds, sometimes thousands of highly specialized compute cores. That's pretty much how a GPU works nowadays. SPIR-V is a thing written by the Kronos group, and it's an intermediate representation which your shader code can be compiled into that isn't manufacturer specific. The same SPIR-V code will run on a NVIDIA GPU or an AMD GPU or an Intel Z GPU, XE. Or you could use SPIR-V in a virtual GPU like Virgil or I think Wine's DirectX makes use of it by emitting SPIR for its shader configurations. But yeah, it's a very neat thing, and Fuchsia has support for that, which means that and the warning that I had at the start of building this, where it was like, oh, you don't have an NVIDIA graphics card. That pretty much alludes to me that Fuchsia has high-level graphics drivers for accelerated 3D and 2D graphics, I would assume. Which, that's interesting. I wonder if they're using Fuchsia as a base for running Stadia games in the cloud. Because when you think about it, Linux is a really stable base for gaming and stuff, but it has its problems, and it has a lot of them. In particular, for Google's things, Linux is GPL, which means they have to release a source of whatever cloud environment that they're building on it, which I'm pretty sure Google has reasons to not want to do that, especially under GPL, because Google actually has an internal document regarding, and it's internal, but it's not secret, I should say, because I can just pull it up right here. And it's a document that specifies what languages Google allows for their developers to work on projects at Google. And permitted licenses. Yeah. So they have a list of licenses that are permitted for open source projects at Google. And they have a framework for coding in the license to make sure that your build tool is fully aware of what license is going into what file so that it can export the license files accordingly, respect the licenses as needed, etc. And Google has this list, and it classes licenses like GNU, GPL, LGPL, QPL, SleepyCat, Mozilla Public License, and reciprocal licenses like APSL, CPL, classes these all into separate categories that Google has different rules on whether you're allowed to include the source file or if you need to get permission from like Google to use this file, or if it just absolutely outright cannot be used in any Google project whatsoever, which is often the case for many commercial type licenses and some copyleft licenses. Like if I go back up here, restricted if statically licensed, the restricted licenses. Now, Google restricts use from using these licenses because their belief is any use of source code under license of this type will taint Google's source code with the restricted license. Now, taint is probably not the right word to be using here. It's more that Google would need to expend a lot of development time into compartmentalizing the project to which they're using this code that's under GPL. And sometimes they do that. Android, for instance, has the Linux kernel in it. Linux is very much GNU GPL v2, and so Google has a headache that they have to manage with keeping the kernel out of their own proprietary stack, which is under Apache license. And this separation of church and state comes up quite a bit in AOSP development trees. It's one of the things that Google handles right, because you can still get the kernel and build it. One of the things they do wrong with it is that a lot of Android kernels are way out of sync with upstream. They don't have features that the Linux kernel actually has upstream, or they have features that the Linux kernel can't and won't have upstream for code or reliability reasons, like vendor proprietary stuff that is under GPL. It's included in the Android-based kernels, but there's good reason that Linux kernel.org upstream, Linus Torvalds, Greg KH will look at this code and be like, what the hell are you doing here? No! And drop it. So yeah, there's definitely room for improvement. And the way Google looks at these restricted licenses, it's a bit of a point of contention. But being that it is as it is, Fuchsia is under a license, I do believe. Actually, let me check here. Do they specify the license on here? Contribute, find a startup projects, tips and questions. Reference, maybe it's under here. Not there. Contribute. Okay. Contributor license agreement, governance statement, code of conduct, community guidelines. Let's see, if I go into contribute changes, what do we have here? So Google has a CLA, which basically makes it so that Google is allowed to relicense any code that you contribute to Fuchsia to Google as their own code. So they can relicense it, they can do what they want with it, commercially produce it, use it for evil, use it for good, use it for launching nuclear bombs. That's their right, because you signed it away with that CLA. Don't delay, CLA. Where is it? License agreements. So there's no big giant sprocket as far as licenses go, as far as Fuchsia is concerned, from what I can tell. They probably have like per component licensing, and certain source files have different licenses. So I'm just going to pop open a new tab, see if there's a big license file on the top. Yep. So just zoom this in. License. This looks like Apache. Yep, that's an Apache license, I do believe. Either Apache or no, not Apache. That's BSD. My bad. That's how tired I am. It's already 9:50 over here. It's dark out, but it looks like the rain's actually letting up, so that's good. It was just a brief storm blew over. No lightning, no thunder, none of that. The severe thunderstorm warning that we had over here with the NWS, that's been dropped, so that's good. Fuchsia's at 27,000 out of 47,000. Is it me, or is that second number gone up? I think it was like at 44,000 before, or 45,000. So maybe compiling these, it's added new dependencies that need to be compiled afterwards. So that's definitely interesting. It's a good thing, and it tracks it rather than just surprising you at the end of the build. And a lot of Rust. The Bluetooth stack seems to be based on Rust. It has rather interesting lib update. So the package manager has Rust in it. That's neat. Yeah, no, when I was starting with Fuchsia, they were pretty much using almost exclusively like C++, Dartlang, mostly Dart for user interface tools and things. Go, there was a lot of Go, and I think that was it. There wasn't really much Rust in the source tree about 3 to 5 years ago when they first released the open source for Fuchsia. So they've added more things. They've advanced quite a bit. Haiku right now is, it's building all the apps and components that make up a Haiku operating system. AROS is still building its tool chain as expected, and I don't need this window anymore. Yeah, right now it's building Fuchsia IO, Fiddle, all the things that it needs for communicating between devices and other services in Fuchsia. Haiku, okay, we're getting the preference panes, locale network, key map. Once Haiku is done building, actually, I could probably, how much RAM do I have left? Let's find out. I have 6.5 gigs of RAM free. All 8 CPUs are being driven at full speed. 40 gigabytes of free hard drive space. I'm going to fire up a Haiku VM. So, here we have VMware, and start up this guest operating system. Should see 4 gigabytes of RAM just disappear. Yep, as expected. VMware is starting up. Let's full screen it. All right. It's going to be a bit slow because all 8 cores are currently compiling stuff in the background. And I think I had the VM set to lower priority. So while these are going and spinning right along, the main VM here is going to be pretty stuck. Oh, there it goes. It is slowly getting itself along. So let's full screen that again. This here. Here we go. All right, so it's pulling down and building the drivers for print drivers. We've got Gutenprint. So yes, Haiku has printer support, and it actually works. I tested it. It handles that pretty well. It's Gutenprint and cups, I do believe. Okay, Haiku's still slowly booting along. Have any other VMs running? Nope. Let's see, systems. I'm not running out of RAM. That's good. File systems. Yeah, hard drive space is slowly running out as everything gets built together. And if I actually do run completely out of hard drive, I'll kill the AROS build process and delete its build tree, because I do know that that does take up a few dozen gigs. I'm actually going to see here. Df-h. Okay, that's, yep. So do I have Qterstat here? Yes, I do. Just pull that open. Have it look at development. Okay. Okay. while that's spinning along, let's monitor the build process. Okay, Haiku has moved right along. When it gets to the rocket, then it'll open the desktop and I can show you what we got for Haiku right now. Because I also do need to update the packages in Haiku. We'll open OS Dev. So right now it seems like Haiku's the largest, but it still has a lot to spin through. So while that's running, let's not open files. Need this window. Okay, Aros is building GCC. Haiku is building network drivers. And Fuchsia is Fuchsia. It's building fiddle. So while Nero plays its fiddle, yeah. This is still going. It's like Fuchsia might be beating Haiku in terms of disk usage. Once it clears all these read jobs. I think this is heads ROM. Yeah, so heads ROM, that would include all of the core boot, so that's got to be pretty large. I don't think I have anything, any customizations to heads ROM that I have committed elsewhere, so I might just delete that tree locally. Rather is peaceful coding out in the game. I'm gonna double check my environment here. The table is wet, not stopping. Yep, none of the electronics got wet. My AC adapter is dry as a very dry thing. I'm no good with these analogs. So, okay, we're at the linking stage. It's building the application catalog. So catalogs are used for telling the operating system what file you're opening with what. Okay, so we got a question from Pony Lover. How did you learn to code? Long story. I started with 6502 assembly on a Atari 400 when I was very young. I was 6 or 7 when I started learning it. I learned only enough basic to get to a machine monitor and start putting in machine code. Like that's where I started learning how to code, because I really didn't care about, like, I thought that computer and like the computers, the PCs that were connecting to the internet and stuff back then were two complete different sets of machines, like that they didn't have anything in common. And video game systems too. I thought they were completely different things. So I was only concerned with myself with this one small computer, the Atari 400, with its 6502 architecture. And all I was concerned with was getting the computer to do exactly what I wanted in the right order. So I learned how to write machine code for it. And I learned what the registers were on the hardware, like the Pokey, the video adapter. No. So that's pretty much where I started learning how to code, was just poking at registers and making things do things, and then putting them together in order. And then later on, much later, where I learned to code like that was books at the library. Our local library had an extensive catalog of research and research materials and books on doing exactly that, programming in 6502 assembly. And they also had 8080 and Z80 resources, but I didn't have any computers with those CPUs in them. They curiously didn't have any resources on like x86 or Windows assembly programming. Didn't have any resources on things like Unix, BSD. Like I think they had a Unix manual, but it was a basic one for a much older, like a Xenix 386, I think. Wasn't exactly, something I could get my hands on as a 7 to 8 year old kid in the middle of Long Island. So I worked with what I got. I learned how to write machine code in that machine. Later on, I got an Apple II E and started playing with that, but we got rid of that because we were running low on money and we really needed to sell it off. And at that time, Apple II computers were starting to get sought after by people who were nostalgic for them. So we made a pretty penny off of that back when I was like 10. But yeah, just slowly iterating on that. I learned deep down into how like gate level logic worked, transistor level components in the computer, and got a logic level understanding of how that machine code was being run through the CPU. And through that, I started to get more interested into like open source software and more high level languages much later on. So that was pretty much that. Most of the things that I do nowadays is just modifying or adding necessary changes to existing code or fixing build automation and on different platforms. I don't really write. I don't really write programs anymore. It's a very long story that I don't want to get into it, but my brain just doesn't function well with putting together code on a screen. If I'm sat at a blank screen and I have to write functions, it's not going to flow well. If I can program and I can describe in detail what I want a program to do. Like, I need this function to call this parameter to this, and it's just, I know what needs to go into the program to make it work, but I just can't put C on the editor. I can't just pop it in and understand right off the bat. I can read code. I can understand reading what it's doing and put together, okay, pointers still trip me up a little bit, but that's more of a, in my opinion, that's more of a fault of the syntax of C rather than the fact that they are pointers, because I understand fully what how the pointers work under the hood. It's just all the stars and ampersands and brackets and sigils. It's the sigils. It's having code that's defined by these weird tack-on structures. I don't like that. I don't like C, and I really don't like C++ for that. And yeah, that's true. Everyone Stack Overflows everything, and yeah, that's all right. As long as you understand what the code is that you're referencing does. Because if you're just copy pasting code and hoping it works, that tends to end up in trouble, to say the least. So, yeah. Right now, Fuchsia is at just about 30,000 in. It's building Garnet right now. One of the components. I forgot what Garnet actually does, but I have a reference, so I can look this up. It's Garnet. So Garnet is on the layer cake. It is device level system services for communication with the system. So Yeah, Garnet's just a services layer for Fuchsia. It's one of the lower levels, so it's reasonably high security code in there. Yeah, Fuchsia is built on basically these 4 components, and it's built on these 4 components. And if you watch Steven Universe, I already see you wincing at the screen right now. But basically, Zircon is where. Oh, but there was that other anime with the weird space rocks. What was it? Anyway, Zircon's the kernel and high-level bootloader, and defines the Fuchsia IDL. Rain's picking up, and there's a bit of wind. I'm gonna go check my environment real quick. Seems fine. Seems okay. Just gotta move this a little bit. There. Yeah. I'm good. So, Zircon's a kernel. Garnet, I just mentioned, is the lower level services layer and provides some high integrity, high security services like the network things. Peridot, from the looks of it, is a library for, it's basically the base foundation, the application library for Fuchsia. So it handles users and stories, which I think are groups of tasks and applications that follow along with the user workflow. So if you're doing a specific task in one category, you'll have a story for that, like for development, programming, and then you would have another story for like web browsing and internet, and maybe another story for gaming, and it would group tasks into those functions and change how the system manages its resources depending on that. And then Topaz is basically the shell and the shell services. So that would include things like the calendar service, which and personal information management, contacts lists, and things like that. Things that you would normally find in an Android operating system that provides all the Elon Musk. All right, so let's see how the progress is on the builds. Still around 29,000 for Fuchsia. That's running through. Haiku is done. Haiku is done. Haiku has built. Meanwhile, my Haiku desktop is up. And yeah, because of the switch from daylight savings time, your computer thinks it is 10:11 p.m. It is 10:12. That is the time. Yep. So here's my Haiku desktop. Pretty basic, pretty simple. I've got this drab color scheme. It's whatever. I do some writing on a program called Ghostwriter, which that's actually going to probably take a second to load because the thing's running in the background. But it's basically a distraction-free notepad for writing markdown documentation and stuff. Okay, AROS is still building as it does. Fuchsia is still around 29K. Okay. I think I saw something just pop open and trying disappeared. But what I need to do here, okay, there's Ghostwriter. So yeah, actually this is the README file for the DEF CON 201 website. github.com/defcon201/site. It's actually SidePocket just linked it in a chat for the actual site itself, and you can go there down to the bottom on the sidebar where the GitHub is linked there. So yeah, this is what I use for editing Markdown files. It's nice. It's distraction free. It looks good. The cool thing about Haiku is Qt apps run in it just fine. Haiku has Qt libraries in it. So what I'm going to do right now is run software updater because I haven't booted this Haiku VM in quite a while, so I'm sure there's plenty of updates to run. And, before I actually do that, I was going to say I'm going to take a system snapshot, but I don't think I do because Haiku has snapshotting built into the system. You can, through the bootloader, by the way, not with an external tool or anything, from the actual bootloader menu, you can roll back the set of system packages that are included in Haiku for that session. So if you screwed something up installing a package and Haiku just does not work anymore, you can just wind it back one. Now, that's honestly a feature that surprises me because Linux only barely has that. I mean, they're only just getting apt integration into ZFS and BetterFS. Windows had that in Service Pack 2 with the system restore rollback functionality, and it only kind of works. And I think now with Windows 10, they just don't have that anymore. All they do is, like, if your system has a screw up, they just have you reset the system. So, whatever. Mac OS, I don't know how it does recovery. I think it's the same way, where you just boot into the Mac OS recovery and reset the system, reinstall the operating system. So, okay, a lot of packages to be updated on Haiku. That is a long list. And it's running a bit slow right now because of all the things in the background. So, yeah, a lot of things that have to be updated, a couple of things to be uninstalled because they're no longer in Haiku or they conflict with a dependency. A few new packages to be installed. Neat. So, yeah. Haiku is going to update everything from async to 0MQ. So, let's go for it. Yes, it's actually called async. Don't, no comment. Anyway, so let's switch back to the real world. And, all right, we're past 30,000 now. Forensic feedback data. I think this is all the telemetry that Fuchsia would normally have, as being that it is a Google operating system. They want to get as much data as they can out of it, and that's the parts that do it. Thankfully, it's only like developer level forensics, so it's like if your program crashes, it'll take logs, and that's actually nice for if you want to introspect what part of what crashed. It just gives you that option to take a deep dive into the system. Haiku over here was already built. This is still doing the tool chain for AROS. It's building the i386 handlers. Right. That's an extra window. Okay. So Fuchsia is still running. I'm going to try running the Haiku that I had just, the Haiku that I just built. So that should be in right there. Haiku nightly anyboot.iso. So let's go back to VMware. That's still updating. So do I have a extra? Okay. I'll make a new VM. Make it custom. Full compatibility. Install the operating system later, because I could say I want to use this ISO, but VMware now tries to install the operating system using the ISO rather than just booting it and letting you install it. It's this new feature they do. I don't like when things make assumptions like that on the system that you're trying to install, because a lot of times those assumptions can be wrong in very unpredictable and bad ways. So I avoid using those kind of automatic things. So our options for operating system are Windows, Linux, VMware ESX. You can actually nest an ESX server inside of VMware, or other. And under other, we have Ecom Station, which OS/2. If you watch NCommander's streams, you know what OS/2 is and why I'm laughing at it. FreeBSD, MS-DOS, NetWare, Solaris, or other. I'm going to go with other because I think that was an i386 I built. No, it's x86-64, so we need other 64-bit. Yes, everyone's still trying to forget. It's hard to forget OS/2 Warp. So I'm going to call this other haiku. Next, 1 core, 1 processor. Yep, I'll do 2 cores. And set my RAM to 512. Haiku can run on less. I've actually seen it run on as low as 192 megs of RAM. But I'm just giving it some legroom. Using that, LSI Logic, whatever, IDE, whatever. If there was an option to not use a hard disk, I would, but right now, whatever. Make a new hard drive. That's 8 gigs should be fine. Next. Okay. Next. And that's done. Now we have a new VM ready to run Haiku. So I'm just going to run to CD drive. I want to use an image. And the image I'm going to use is development OS dev Haiku generated. There it is. Oop. Save. Make sure I got enough RAM to use this. Drive space is down to 29 gigs. That's fine. Yeah, I've got about 5 gigs of RAM free. I can run 512 megs of RAM. That's not a problem. Start this up. All right. So here's an interesting thing. When you build your own Haiku, it does not include Haiku branding. So the boot screen is just the strip of icons, the row of icons, does not have a Haiku logo, and that's by design, because Haiku is a trademark of Haiku Inc. in the US and other countries, registered trademark. You don't want to be misusing their trademark when you're demoing a custom operating system that's built on the Haiku code. So what I'm running is technically not Haiku. It's legally not Haiku. It's an operating system that is built from the Haiku source code. But this right here, what's on my screen, isn't Haiku. I do have actual Haiku in another VM running in the background. But yeah, that's legally not Haiku. I can't call it Haiku. Actually, I should rename the VM if I can. Haiku. Yeah, there we go. It's the opposite of Haiku. It's Baiku. So, do I want to install distro name or try out distro name? Yeah, so that's another thing. because, like I said, branding, Haiku owns a trademark. You wouldn't want to distribute your own fork and run afoul of their trademark. So by default, it just fills these fields with distro name. So actually, I'm going to rename it once again to distro name. There we go. So we're gonna try out distro name right off the live distro name disk, and in a minute, yep, this is what distro name looks like. It curiously still calls the root file system Haiku, but don't be tricked. This is very much not Haiku. This is distro name. The default set of applications, like you have the usual pref panes, has its built-in component of applications. So it built successfully and it's running right now. No problems here. Let's do GLT pot. And as you can see with the monitor up here in the corner, it's throttling the CPU rather hard. And there it is. That's a 3D teapot. Look at those FPS. In fact, I think I can do this. Yes. So there's another teapot. And the FPS is now cut in half. More teapots. More teapots. More teapots. Yeah, I'm just going to keep adding teapots. And now it's really struggling. So, yeah. Haiku does OpenGL in software, by the way. So it's the reasoning behind that is that they don't see a reason to try right now to get graphics accelerants working. So they pretty much deferred that since we have basic frame buffer graphics working as it is. They deferred all the 3D graphics stuff for later while they work on the core of Haiku and get the user experience, the desktop and operating system going. So, yeah, that was distro name. Let's go back to the Haiku desktop and see how this is going. 47 packages updated. All right. So now that Haiku, or rather distro name has been built, let's see here. Eros is still going. It's still building lib standard C++. That's fine. That'll do. Let's see how Fuchsia's going. 30,000. It's building accessibility tools, the magnifier. Okay, so it's going through. It's doing its thing. So while Haiku downloads its package updates, so Haiku has a rather full component of applications for development. It's really well put together for if you want to just get into writing code and having an environment that's mostly distraction-free. You get a shell with the usual base core utils from GNU, or are they BSD core utils? I don't know. But uname, yeah, it tells you it's Haiku. It's a little older build. I haven't updated it in a long time. But in the Haiku depot, which is where you get packages and applications for Haiku, is this cool thing. It's called Zeal. What Zeal does is it's a library of documentation for programming languages and things. And it pulls down all the... Not the moon? I think I can see the moon through the trees. Spooky. But the Zeal pulls down documentation locally and synchronizes it with the upstream repositories containing the documentation. And it's a good resource to have for if you're learning and building programs and writing new code and stuff, because you can have that on your computer, not connected to the internet, and work in a distraction-free environment and get things done. So Haiku is going to be a bit slow. Wow, that's some very Windows 95 look right there. Welcome to Windows P, guys. Oh man, so it does that because the virtual machine that I'm running is on a lower priority than the build jobs that I have going in the background. So those are all doing their thing. With the CPU being, the virtual CPU being of a lower priority, it runs an effective lower clock speed. So it's probably the equivalent of like 200 megahertz right now. Being that it's running as slow as it is, the windows are moving, but it's not updating the frame buffer. It's not doing a dirty window cull, is the technical term for that, where it looks for the mask of space where the window is being drawn and clears it over with the contents of the window below it. That is a thing that it's quite resource intensive, and constantly doing it will hurt performance on the system. So the window culling is usually deferred while drawing and other UI things are being done in closer to real time. So it's the same thing on Windows XP. That's the same effect that occurs, and that's the same reason why that effect occurs. It's because the CPU is being busy. It's not got enough cycles to throw towards this. So a higher priority task is going to be running before it does the dirty culling on the windows. Anyway, so see what's gone through so far. Right now it's updating GCC inside of Haiku. So Haiku, all the packages are binary packages. Programs are compiled. There are source packages as well, but the infrastructure for that is kind of broken upstream from the last time I tried to use it. So they'll work on it later. It's not a huge priority because they can do source packaging as they need to in the build tools underneath Haiku. But Haiku packages are binary, and the packages themselves don't extract to the file system. They don't unpack and throw files all over the hard drive. Instead, what they do is they overlay on top of the file system. And Haiku uses the B file system with its own enhancements and reliability features, because B file system was notoriously bad for it wasn't journaled. It didn't have any it had rather poor atomicity. So if you killed your computer while it was doing something file wise, you'd run the risk of losing data or corrupting file system components. So Haiku took the old file system, made it much more resilient, expanded on it, and that's pretty much where it is. They are looking into other file systems. I think BetterFS was one alternative that they were considering, but it's still a long ways off. They have a working file system as it is, and don't break what's don't fix what ain't broken. So let's see how the progress is on these. Okay, so Aros is now compiling OpenGL. I actually didn't know it had OpenGL support, so I wonder if that's in hardware or software. It's almost certainly going to be in software, because Haiku's OpenGL is in software. Fuchsia's at 32,000. It's building Zircon test harnesses and frameworks. So cool. Now it's on to libpng. Aros might be done rather soon, actually, because it's now just doing workbench dependencies and libraries. And yes, it says Linux i386 because this is hosted Aros. What it is it actually builds into a environment that is pretty much virtualized underneath the Linux syscall interface. So it's i386 code running, and it just communicates to Linux rather than to hardware. So for graphics, it pops up a window. I think it uses SDL, sets up a frame buffer, and then Aros writes to it as if it were a hardware frame buffer. Meanwhile, the rain has stopped. So yeah, it's no longer raining here, which is nice. C. Okay, cool. Aros is doing its thing. Fuchsia's at 32,000. And Haiku is downloading its packages as needed. Okay. Actually, yeah, let's go back to QDirstat real quick. So OS Dev, I have a total of 40 gigs worth of, and of that 40, 36 of it is being used by Fuchsia. So definitely not a small operating system. For comparison, Haiku is only using 8 gigs of the hard drive, and I have 2 Haiku trees in there, so it's probably quite a bit less than that. And Aros is right now at 3.5 gigs. All right, so three packages done. I thought I clicked on Zeal before. I guess it just didn't open yet. So hopefully it starts loading here. My battery's at 81%. Come on. Yeah, Zeal is running. It's a process, so I don't know. Maybe it's just taking forever to boot up. There it goes. All right, so yeah, so Zeal's pretty neat. Over here you have a list of all the documentation that you have downloaded, and like I have OpenGL API, processing language. I pretty much downloaded everything I had available because I just had the hard drive space, and it's good to have a library of documentation on hand. So, for instance, if I go to C here, and it opens a C reference, and the documents are HTML based. So it's basically it's a library of HTML documentation file. It's just compiled down into a library file that this can access from. So yeah, you have a C reference here, and expand this. Yeah, you pretty much go through, and if you need to look up something real quick, you've got a search function here. It's just a little embedded web browser in the window. You even have Dartlang. Let's see what doc sets need to be updated. Probably all of them. Oh yeah, quite a few of them need an update. Yeah, I'll do that all later. X out of that. So yeah, like I was saying before, Haiku packages don't extract to Failed to download package. Okay. So let's rerun software updater. Okay. All right. So, okay, so it failed to download one package, so now it has to redo all of them. Did it cache anything or update now? I mean, granted, that's probably good on it that it isn't, keeping a state that's unstable, but it's still annoying because it has to now go and download. Unless the connection to the Haiku server is no longer available. There it goes. Now it's downloading things. Yeah, it now has to download another 203 packages. So, whatever. That can run in the background. So, let's go back to here. 32,000. It's okay. Some platform files and interfaces for hardware. It was done. Make depend. Okay, so now it is building the components for AROS that go into quote-unquote ROM. So the way Amiga is structured is that you have a ROM set, which includes the workbench and the basic framework of the operating system, kind of like how Mac OS does it, where you have a toolbox ROM and all of your OS syscalls and functions are in that toolbox, and you call to them from code that's on a floppy drive or the hard drive. AROS carries that over in a way. So what's ROM in AROS is kind of in between what you would call a init-rd and a part of the kernel in Linux. It's things that are loaded into the RAM and mapped to a structure in place that can be called into from applications. So these are static libraries. They stay right in the memory all the time whenever the system's running, and provide basic services like graphics and graphic sound, file system, things like that. Okay, boot animation did not compile. I hope that doesn't break the build. But yeah, it's a rather interesting architecture because it's all based on Amiga OS. So it has to do things kind of the same way that Amiga OS did. And unlike with Haiku versus BOS, where they originally started with implementing BOS, ABI, and API, and meanwhile, while they're working on that, they still advance the operating system beyond what BOS could do originally. AROS is quite a bit more conservative in its approach. Like, it's ported to x86, which is already a huge changeover, and PC architecture is very different from Amiga hardware, but it still does it still does change over to it and works reasonably well. Okay. Filing utility functions. Okay. That's all has to be expected. One thing you can't see on the stream is that on my screen on my computer, there's bugs crawling like all over it from it, just because I'm outside here, and but yeah, because I'm outside here, it's dark and the screens are bright. Bugs are attracted to the light of the screen, and they're just crawling on it. So it's neat. I'm doing occasional debugging time and again. All right, so hopefully this finishes in a reasonable amount of time. I'm actually this looks like it's going along. If Aros hasn't finished building in about, let's say, 5 minutes, I'm gonna kill this off and focus all of the attention on Fuchsia for the computer, and that means also shutting down the virtual machine. So yeah, right now that's going right along. Okay, so I'm going to cancel this software update. Quit. And of course it crashes because they probably didn't handle some kind of cleanup on the termination. So whatever, just shut that, exit that. And I'm going to suspend the system, not shut it down. I don't have any other operating system running. Okay. Hopefully my mouse stays intact. This is finished shutting down. Yes, good. So like I said before, VMware does have this bug, and if that bug were to happen, I'd have to shut the lid of my computer and reconfigure the stream. But so far, so good. Close out of VMware. Close out of Qt. It is compiling and linking debug stuff. Unit tests. Okay, that seems to be going at a reasonable pace. Close out some of these extra windows. Haiku is done. Fuchsia. Okay. Yep, that's all running as it should be. This is, yep, that's fine. Okay. So, you might have noticed up here, it is compiling and linking and debug things for something called Zune. Now, this is cool. They had the name Zune long before Microsoft made their the MP3 player that everyone seems to have forgotten about. Aros had that name before then, and what Zune is in Aros is it's the window and widget toolkit. So it's like GTK or Qt. It's just the thing that Aros uses to draw windows. And the thing with Zune is they have Zune and Intuition. And Intuition is their Amiga OS 2.0 compatible. You know, original, classic, more conservative window and widget framework. And that has an API that's very familiar to someone who develops Amiga OS programs, whereas Zune is a brand new object-oriented weird thing with its own layout engine and everything, and it's neat. They recommend that if you're writing applications for Aros rather than porting them, that you use Zune instead of Intuition. But Either way, it's just one of the widget toolkits for AROS. It's the one they recommend you use by default. Okay, so it's building free type right now. That handles fonts. If you couldn't already tell from the TTF and true type files here, free type is a very, very widely used library that draws characters out of font files and handles font data information. Has a reasonably sane API, and you can call it into embedded code that's even things that are running on tightly embedded systems like Nintendo Switch, for instance. You don't have much of an operating system to work with there, or the Nintendo 3DS. But FreeType can run in there and still draw characters because it doesn't have a big set of dependencies on anything in particular. It just does its thing. Does its thing and stays out of the way. So, AROS is zooming along as expected. Fuchsia is at 34,000 right now. Okay. It's, again, compiling SPIR-V tools. I already mentioned what the significance of that was before. It's graphics shaders and tools for that. Okay. It's compiling Amiga DOS tools and APIs. CDFS, so ISO 9660, HFS, and Joliet. Okay. This might be done reasonably soon. Okay. Oh wow, this is going right through. Yeah, doesn't have things to compile right now. It's just running timestamps on files, and every now and then it finds something it needs to compile. But for the most part, it's just breezing right along. Okay, Haiku is done. I'm done with this. I can exit this terminal. AROS is still going. Oh, that moon is bright. Lighten up the clouds. Must be a full moon out. Yeah, so here I am coding under moonlight. Okay. Workbench. So if this isn't done in about 5 minutes, I'm gonna wrap up AROS, and hopefully Fuchsia should be done quicker without having to compile two things in the background. Monitor the system. All the CPU cores are spinning at max capacity. Memory is down to 4.5 gigs of usage. File system, I have 20 gigs free. That's starting to run a bit thin. Okay. It's compiling the AROS shell now. So, all right. Install grub. Okay. Didn't know they had grub tools pulled in. I thought it was just like doing the grub thing from the build system. Now, I don't know why it's building grub considering this is hosted AROS. So there would be no reason for it to be installing a bootloader because it would just be running as a Linux application. But I think it just goes through and builds everything just for the sake of it, because it doesn't have to change much on the things it's building to make it run as a hosted application. It's just basically a shell goes up around the system environment, and all the syscalls get dispatched to Linux rather than to native hardware. So, okay, it's going through compiling free type once again for some reason. Or maybe it's just like it was doing a few other things in the background and working out dependencies. Okay, let's go back to Fuchsia and 35,000. It is building the graphics engine for the UI. So, scenic. I'll give this about 2 more minutes, and if it isn't finished before then I'm just gonna kill the build process here. Okay, we're at 35,000. It's still building the graphics libraries. Bench classes, libraries here. Soon. Okay. Okay, I'll let this build about 2 more components, and then I'll call it quits on the AROS build. And okay, MUI master, all the classes for that. Wanderer. Okay. Let it finish building Wanderer, and yeah, if it still has more crap to do, I'm canceling this build, and we'll focus on Fuchsia. Text editor. Okay. Still building Wanderer. Workbook. HD toolbox. Yeah, it's still got a ways to go. So, you know what? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and yeah. Bye. Okay. That's it for AROS. It's not gonna build in a reasonable amount of time with Fuchsia trying to do its thing in the background. If I look at the resources, yeah, quitting that, it made a blip in the CPU usage here and here, but it's already been reuptaken by the build process for Fuchsia. We've got about 10,000 more components to build there for Fuchsia, and hard drive space is down to 17 gigs free. Doesn't use a lot of memory, surprisingly, like only 4.3, 4.4 gigs. I say that as it was building the memory stress test function. That's funny. Definitely going a lot faster now. So, oh man. So I'll let this run for about 3 more minutes, and if we don't have something by then, that will wrap the stream. So right now, Paver. Okay, so Paver is actually an interesting thing about Fuchsia. It's what you use to install, quote unquote, the Fuchsia operating system. And the reason they call it paving is because you're basically flattening the disk and putting a foundation onto it for which Fuchsia can be written to. And it doesn't really intend to be installed in a dual boot environment. So they haven't written any tooling for, running Windows alongside it or anything like that. So when you install Fuchsia, whatever target it is you're installing it to, it actually boots a tiny Fuchsia OS that is used to pave the target. And that connects to the network. It has just enough services to be able to locate a running Fuchsia instance that's being served to it. And then the host from which you're building it will basically it connects to that paver and sends over the files that need to be installed to it. So it's kind of like a netboot installer for like Windows or Linux or something. Okay, we're at 36,900. It's all the Bluetooth stuff. Man. I wasn't expecting to be using the smaller computer. I had a rather beefy ThinkPad, 8-core Xeon, 32 gigs of RAM, and plenty of hard drive space available. And it was going to get a fresh install of Ubuntu and run the build for Fuchsia in its own environment. But the Ubuntu install kind of failed midway. It kept crashing X whenever it wanted to load it up, so I had to get it back up and work with it. Excuse me. We're at 37,000. These are the PCI and virtualization drivers. All right, graphics drivers for Mali, Intel. Virtualization. Magma, that's neat. I don't know what that's for. Probably has something to do with Apple, come to think of it. Probably something like the Metal graphics API. That's just a guess. I have no idea. Did I just see Banjo? Okay, it's breezing through this now. 38,000. Okay. 38.2. Did I just see Donut? I thought I saw donut.exe for a second. If you couldn't tell, I'm getting a bit hungry. All right, so if this build doesn't finish in the next, let's say 5 to 7 minutes, then I'll call it an end for this stream. Okay. $39,000 now. These are i9-15 graphics drivers. Okay. Intel HDA audio drivers. We're at 40,000 now. All right. And 41,000 coming up, and there it is. Yep, it's basically we're just looking at a progress bar go by. That's real exciting. So after this finishes, then next step we're going to have to be doing is, it's setting it up to run on an emulator. So they have an emulator that they call FEMU, like QEMU, but for Fuchsia. It's okay. Basically you just do a build, FX build, and then set up, and you run FX VDL start, and that gives you an emulator instance. Okay. This is at 43 out of 46,000. Okay. 44. Okay. Input options. My default use is multi-touch. You can use the argument pointing device mouse for mouse cursor pointing. Okay. Run it headless without a GUI. Hardware, host CPU, host GPU. Interesting. Okay. Graphics acceleration. Yeah, see, this is why I wanted to use the ThinkPad P50 that I have, is it has an NVIDIA Quadro M4000 M graphics chipset in it, I believe, and that's supported directly by Fuchsia and the Fuchsia emulator. So we won't have graphics accelerated GUI here in the demo when it comes up, but okay, 44,800. Cool. 44.9. Wow, that's zooming right along. This might be done before the before I decide to end the stream. All right. So we've already done the FX build. We've already set up a QEMU TUNTAP link. So let me just double check something in my environment. Echo cache Fuchsia _ root. That's not defined. Did I spell it? No, I didn't. I didn't spell it right at all. Still undefined. Okay. All right. 45,100. Yep. So this seems straightforward. Launcher. Okay. So I'm assuming that would have been the desktop launcher, similar to a launcher on Android, pretty much. Okay, 45200. Okay, so let's check this out here. So here it says FEMU is based on the Android emulator AEMU, which is a fork of QEMU. Okay. Due to legacy issues, there may be references to AEMU. All right. FEMU looks and behaves like a Fuchsia device, with the exception that no paving is required. Now, what devices does Fuchsia actually support? Did it actually say here? Yeah, installing Fuchsia on a device. So, building, creating install media, paving. There's an option for Pixelbook and Intel NUC. Set up experimental hardware. Acer switch, IMX8M EVK, Catus VM2 board, and Tulos. A Jetway PC. Fuchsia developers use a platform for writing networking software. So I guess they intend on Fuchsia being used for like routers and network hardware as well. And one of the systems that they are testing it with is this Jetway 130 to 731 series. What a remarkably memorable name. The Skylake base has DDR up to 16 gigs. Has a SIM card holder and supports TPM and it's a console. Yeah, it's just this box. It's like a router box. Like one of those kinds that you would install like FreeBSD, something like that on it. I think this is the wireless version, or maybe that's the other side of this one. 10 ports out the back. HDMI output. I guess if you need HDMI in a router, sure. But yeah, it's a neat device. I wonder how much it costs to get one. Ordering information. That's just information about the device and its configurations. Yeah, you would have to submit an inquiry to get a price. I'm not going to do that. That's outside of my pay grid. So let's go back to Fuchsia, and we are at 46,583 out of 46,693. So we're 110 steps out from a complete build, from the looks of it. Okay, so component manager, that's going to be a rather large component in and of itself. So that's probably why it's taking its time on that one. CPUs are all maxed out, as expected. Available 4.7 gigabytes. Oh, I should probably free up some space while I'm at it. Yep. Let's go to haiku. And I'm just gonna -rf haiku because I don't have anything of any reasonable need over there. 46676 now. That is almost done. We got 6.9 gigs free. Nice. It's done. It had finished building. Sweet. All right. Still deleting haiku. Big W's there. Yeah, so this is what we have, and df-h, we have 15 gigabytes free. Let's see here. What else can I remove? Let's kill off the AROS tree while we're at it. Okay, and that brings us to 20 gigs. 20 gigs should be enough for anybody. So, back here, FEMU. Going to fxvdl start -n. So let's fuchsia root in. Oh, I guess that's actually just the fuchsia there. So, excuse me. Exit here. fx vdl start -n capital N current directory / script / start insecure internet.sh. And yep, that is the entire -u. Start -n -u. Yep, that's it. Let's run it. Okay, it's going right along. Setting up a FEMU environment. Needs sudo for that. Cannot start Fuchsia emulator. Failed creating a device. Exit status is 1. Okay. Let's see. Disable analytics here. And paste. Well, that's great. Tells you that's how it disables the analytics, and it doesn't recognize that. Okay. FAD properties 1280 by 800, 192, RAM 8 gigs, screen density 240. Do I even have 8 gigs of RAM free? Yeah, I do. Okay. Let's try rerunning this. Let's see what happens. Okay. I guess it can't do the network, so let's just do that. Nope, cannot start Fuchsia emulator. Failed creating new device. Exit status is 1. Let's figure out what's causing that. Big ass mosquito. Holy hell. You know what? I think I'm going to call it for today because the Fuchsia emulator is not wanting to work. It's not wanting to cooperate. Oh, wait, what? Nope, never mind. We got a screen here. Holy hell. Okay, device is not up yet. Waiting for emulator to start. Weird. Yeah, I've got Fuchsia running. Okay, cool. So this is Fuchsia. And let's see. Extended controls. Let's see here. Settings. Okay, these are settings for the emulator. That makes sense. Android is always a sweet treat. Okay. So this is the yeah. Let's see. Control. Oh. No. Oh, that's for multi-touch. That's what it is. Okay. Let's see. Control 2, F3, Alt F1. No, that's F2. So I have Fuchsia quote unquote running, but I don't have a desktop here. It does have a shell here, so let's see. Help not found. List. Okay. So we have a file system here. Okay. Yeah, it gives you their default core utilities. Interesting. So what would I need to do to get a user interface on the emulator? So okay. Explore Fuchsia. Here we go. So device commands in Fuchsia use the command DM. So, DM help. Ah, okay. Launch a graphical component. Okay. Let's just do this. Can I paste from here? Actually, that doesn't look like I can. Maybe if I... Okay, so I have this shell. I can paste that in. Now, is it actually running something? It's probably in a background shell. I probably have to hit the connect to a target shell. Right, for Fuchsia. Contribute changes, FX workflows, configure editors, scenic example apps. To use the shell, press Alt Escape in the console mode, Alt Tab. But Alt Tab doesn't. That's on the host. That's not. Control Tab doesn't work as you would expect. Alt Escape. See, the problem is I think the host is capturing too many keyboard commands, so I can't actually interface with Fuchsia as I'm supposed to. Control 1, 2, 3. Alt 1, Alt 2, 3. No. Control 2, 3. No. Yeah, I actually don't know how to get to any of the other shells from here, especially the graphic one. So, you know what? DM power off. I'm actually going to call it quits for this because we at least got it built and we got it booting something. That was the Zircon shell with the, that was the Zircon kernel with its shell. So I'm pretty much done here, but I'm going to see how much space this actually took to install. So du-h du-. I just want one depth. So D1, okay. du-h-d1. Now it's running through and figuring out how much space the Fuchsia. I could do this graphically. So 58 gigabytes. It uses up nearly 60 gigs of your hard drive to build Fuchsia. And I'm going to do this graphically and show you what components of what the heck? True development, OS dev, Fuchsia. Okay, so most of it is in the out directory, and those are the built components of Fuchsia. That's everything that's been being built while I was waiting for it. A lot of it is pre-built, and of that, it's all third-party stuff like Rust, Clang, LLVM, and stuff. It's rather nice that it downloads pre-built for Linux x86-64 because that saves a lot of compile time and a lot of hassle building them. Third-party, we have Unicode, ICU, Boring SSL, Dart, Go, Mesa, some parts from Android, like Bionic C. So, yeah, has a bunch of stuff there. And aside from that, the Fuchsia source itself is only like 200 megabytes. And this is the entire tree here. Most of it is in libraries for connectivity, especially WLAN. I bet a lot of that is the firmware. Yeah, IWL Wi-Fi. That's going to contain firmware files and stuff. Bluetooth network, same deal. Libraries, you got a good stack of libraries here. Vulkan, async, storage, developer stuff. So you have debug tools, virtualization, rather neat. So yeah, altogether, Fuchsia is a small code base. It just takes 60 gigs to build on your computer for some reason. So that's pretty much all I have to show for Fuchsia. That's how long it took to build, about 3 hours on a shell. Yep, I don't have it. So whatever. head/proc/CPU info. So yeah, i7-8565U. It says it's 1.8 gigahertz. It actually runs quite a bit faster in real time. 16 gigs of RAM. It's a laptop that you could use for developing, and it still took that long to go through everything and build it. A 1 terabyte SSD on NVMe as well. So it's like, yeah. Anyway, I guess I'm gonna wrap it up here. So thank you for watching, and let me just poke Side Pocket and let him know that I'm ready to go. So yeah, that's been Circuit Breakers. I'm sirocyl. You can follow me on Twitter, twitter.com/sirocyl. Join us on DLive, YouTube, and Twitch in the future. We'll have plenty of more streams as crazy or more than this. And yeah, that's been Fuchsia, the experience of building it and 3 other operating systems as well. If you have any questions, feel free to poke me on Twitter or whatever, and I'll let SidePocket take us away from here.